Okay, today we're going to study a very specific type of parallelogram. So far, all we've looked at are parallelograms in general, and we have at least four properties there that we can think about. Opposite sides are parallel, opposite sides are congruent. We also have that the diagonals will bisect each other, and then opposite angles are congruent and consecutive angles are supplementary. Those sort of go hand in hand. Well, the rectangle adds a couple of layers to that. It has all of the properties of the parallelogram that we just described and that we've been studying for the past week. But a couple of additional properties is that the rectangle has four right angles. Okay? As a consequence to that, because it has four right angles, the diagonals are also congruent. So in a lot of ways, the characteristics of this are even more specific, and it's going to make our lives even easier because we have a lot more freedom in terms of what we can set up. For example, if I have one angle and I know it's 90, I know all four are 90. There's not going to be a situation like we had in the last section on the last quiz where maybe this angle is 50, and then I'd have to know that this angle is 130, and then this is 50 and this is 130. With the rectangle, we don't have that. They're all 90, which makes it a lot easier to deal with. So let's look at an example of a rectangle, and we're going to keep coming back to this same picture that we have here of rectangle ABCD. They tell us that it's a rectangle. So as soon as I know it's a rectangle, I know that I have 90-degree angles. Okay. I also know, like I knew before, that the diagonals bisect each other, but even more specifically, the diagonals are equal. So all four of those pieces in there are equal to each other. So what you have are some congruent triangles because of side angle side and vertical angles. So we can make use of that. And then we have another pair of congruent triangles here. Okay, so we want to make sure that we observe those relationships. And then, just like any other parallelogram, opposite sides are equal. BC is going to be equal to AD, and so on. So let's take a look at what they give us here and what they want us to solve for, and see if we can set up an equation in order to do that. So here they tell me that AE is 36. So that's just this short segment from here to here. That's 36. And then they tell me that CE is 2x minus 4. Okay, so I really don't need any specific property of a rectangle here. I know that the diagonals in a parallelogram bisect each other, so I would know right away that 2x minus 4 is equal to 36. And we just want to solve for x here. So I would add 4 to both sides. And we have 2x then equals 40 and divide by 2. So x is 20. And again, keep an eye on that same parallelogram or same rectangle up at the top there as we take the information that they give us to set up our equations moving along. Here they tell me that BE equals 6y plus 2. So that's just that piece there, that singular piece, that's 6y plus 2. And then CE equals 4y plus 6. So we can see CE is 4y plus 6. That's right over here. Well, we know since the diagonals are equal and they bisect each other that we're going to be able to say that 6y plus 2 is equal to 4y plus 6. And then we'll go ahead and solve this equation for y. So I would subtract 4y from both sides. So we have 2y plus 2 equals 6. So we could subtract 2 from both sides. And we have 2y equals 4, and then divide by 2. So we just have y equals 2 for that second one. Okay, so got a little bit bigger picture of our rectangle here. I think that might be helpful. Here they tell me that BC is 24, and then they tell me that AD is 5y minus 1. So we know opposite sides are equal to each other. So we're going to be able to say that 24 is equal to 5y minus 1. We'd add 1 to both sides. So 25 equals 5y, and then divide by 5. So we would just have y equals 5 in that algebra situation. Same picture, different numbers. BEA is 62 degrees. So where does BEA live? 62 degrees is right here. find the measure of angle B to A to C. So where does angle BAC live? We're looking for this angle here, right? But keep in mind, we have an isosceles triangle here, right? All these diagonals bisect each other, and the diagonals are equal to each other. So if I have an isosceles triangle with a vertex angle of 62 degrees, which is what I have, remember that these two base angles are equal. So we would take 180 minus 62, right? And that leaves me 118 degrees. But remember that 118 degrees is the total of both of those angles. So we would take our 118 and we would divide that by 2, and I think we get 59 degrees in that situation. So the measure of angle BAC would be 59 degrees. Right? What we have here is 59 degrees here, 59 degrees here, and 62 degrees would give us 180 degrees in that triangle. Okay, now we're looking at 5 and 6 to finish up our algebra examples here. Again, we're focusing in on some angle situations. So they tell me that the measure of angle A to E to D, let's see where that lives, is 12x. So that's an angle. We're talking about this position here is 12x. Then they tell me that B to E to C is 10x plus 20. Well, where's B to E to C? Those angles are vertical. So right away, I'm going to write down over here that I know 12x has to be equal to 10x plus 20. And they want me to find the measure of angle A to E to D. Well, they told me that A to E to D is 12x. So once I know what x is, I'll be able to plug it back in. This will be a two-step situation to solve for x. So we come back to our equation, subtract 10x from both sides. So I have that 2x is equal to 20, and then we'll divide by 2. Okay? So here we have a diagonal B to D. And we know, remember, diagonals are equal. That's 8y minus 4. That's the whole thing. The whole diagonal from one end to the other is 8y minus 4. Then they tell me that AC is 7y plus 3. Well, AC is the other diagonal. Remember that they're equal to each other. So 8y minus 4 equals 7y plus 3. And let's consider what they're asking us for. They want BD, which we know is 8y minus 4. Just realized, let me pause the action here for a second, and we'll go back up and finish answering number 5. The measure of angle AED, forgot to say, should be 12x, which is 12 times 10, which would be 120 degrees. Got ahead of myself there. Okay, and now finally, remember, we'll have two steps here. We want to find BD, which we know is 8y minus 4, but first we have to see that the diagonals are equal to each other. That gives us an equation that we can solve. So 1y minus 4 equals 3, and this solves pretty quick and painless and easy for us. We get y is equal to 7. So if y is equal to 7, remember they want BD. So BD is 8y minus 4. Could really plug into either one since BD and AC are equal. We should get the same answer. So this is going to be 8 times 7 minus 4. So 8 times 7 is 50. So we have 56 minus 4 would be 52.